Well, hello everyone. This is us on the second last subtopic. What we're going to be essentially doing is putting together all the different things that we've discovered in the earlier 7 and putting them together so that we can come up with a pretty detailed, not perfect, but a pretty detailed sketch of any rational function you might encounter. So it's a bit like a shopping list. And so let's have a rational function that's got all the different kind of pieces in it that you might expect. That's this one. Now I've chosen a nice simple one that's already factored, because factoring does help in many of the processes. Not all of them, but in many. Now, if you want to go through the hit list, let's do it. What's the domain of this function? Well, the domain of this function is you can't use -3 or 5. So you can't use -5, and you can't use -3. So I'll call that A. Now, we don't normally ask you to calculate the range. You really can't tell algebraically what the range is going to be until after you've sketched it. So when we get to the end and we can see a sketch of it, I'll then return back to what the range is. Now let's go hunting for x-intercepts. And there's no cancelling going on here, which is good. So I can tell you that the x-intercepts are going to happen when the numerator, the top, is 0. And that gives me 2 x-intercepts. So the x-intercepts have coordinates. You should always do them by coordinates of -1, 0, 2, 0. If you write that down, for instance, in Weberson, what you're saying is a vertical asymptote x equals -1 and a vertical asymptote x equals 2, and that's not what you mean. You're trying to tell me a specific x-intercept coordinate, which is not the same by any means. Vertical asymptote. So that was it. Let's find y-intercept. Well, all I do is find the value of the function at 0. So what's that? 0 plus 1, 0 take away 2, 0 plus 3, 0 plus 5. So I get -2/15. And again, you don't say y equals -2/15. It's a coordinate that you want. So the x-intercept is 0, -2/15. Now, what we're going to do next is we're going to do horizontal asymptotes. So to get a horizontal asymptote, you have to do a bit more work. This is a situation where the factoring isn't helpful, because to be able to do the surgery, as I called it, you have to follow these guys out. And then you can say that it behaves as by only using the biggest power of x on top and bottom. In this case, is 1. And so I have a horizontal asymptote, and I do use y equals, in this case, 1. Now to do the next fella, let's find vertical asymptotes. You take your rational function and you find out when, for what values of x, is the bottom 0. And that gives me 2. those guys. But I also want to find their shape. So for each one of these, I'll do some test points. Obviously that negative goes before that one, but we can sort that out later. So the test points I'm going to choose here are negative 3.1 and negative 2.9. And for this one, I'm going to choose negative 5.1 and then negative 4.9. And for each one of these guys, I'm going to get the y values. Imagine me going to the calculator and typing these in and coming up with some values. So bear with me for a few moments. I'll tell you what you're going to get. Negative. We're going to get a negative answer there. And negative. You're going to get here. Positive. Let me check this one. Negative. That's negative. Positive. Okay. And here, negative. Positive. Negative 5.1, negative. And 4.9, negative, positive. There you go. So that's what you would get. So we're getting pretty close. Oh, by the way, if you have a horizontal asymptote, you cannot have a slant asymptote. Right? You can either finish life like that or you can finish life like that. You can't be both at the same time. So the fact that this came out as a horizontal asymptote means I don't need to look for the equation of the slant asymptote. However, if I did this surgery and I ended up with the answer 2x or 4x cubed or something, that would be a slant asymptote and I would have to do long division to find its equation. But thankfully, that doesn't happen too often, although you will see it a few times. So this is a bit quicker. And so let's start putting our information onto our grid. Well, I know that it has an x-intercept at -1, which I'll put here, and at 2, I'll put here. It has a y-intercept at -215, so I'm going to put that there. It has a horizontal asymptote of y equals 1, so I'm going to draw a horizontal line y equals 1. It has a vertical asymptote here. And I just realized we didn't plan ahead. So planning ahead now. And we have our second vertical asymptote over here. So one is x equals -3. The other is x equals -5. That's good. Now let's see what we have. At x equals -3, we have a negative. And at 2.9, we have a positive. And this one here at -5, we have a negative. And at 5.1, we have a positive. We have a horizontal asymptote, so I know that it's going to level off in that direction. And let's see what I've got over here. Well, it has to come and it has to get to there, and then it has to get to there, then it has to get to there, and then it has to flatline. Now, it may or may not cross that line, but it'll definitely flatline. That is almost my shape. So what's left here? Well, I can't cut the x-axis, and it's kind of natural to imagine they just come round. So my prediction on this rational function is this guy. So what I'm going to do right now is I'm going to go to Desmos, and we're going to see how good a fit that is. So click on it. Here we go. Type it in there. It's y equals on the top x plus 1, x minus 2, and then on the bottom x plus 3, x plus 5. Now you can see that it's got a little bit of an issue, and so I'm trying to adjust the windows to kind of suit the scale I've got. I went to about 5, so I'm gonna, and this fella here is gonna have to go. Well, there we go. Now, some of the features don't show up easily on this scale, so I'm going to have to choose two different scales. First scale I'm going to do is that. Can you see the vertical asymptotes at -5 and -3 with exactly the shape I said they had? What you can't see very easily is the horizontal asymptote at 1. So what I'm going to do here is going to do this guy. Now, can you see the x and y intercepts? And now I'm going to do this guy here. And as I scan it along, there, are you convinced now that there is a horizontal flat line at y equals 1? So you can't see all the features in one scale, and that's just the nature of the beast. But you know what all the various pieces look like. Now, if I scroll out a little bit and maybe try and adjust my scale as a compromise, um, uh, and we seem to have missed x equals -3. Oh, there it is there. Okay, we got our x equals -3. So where is our x equals -5 guy? He's hiding in there somewhere. Didn't manage to get both features at once, but it could have been better. But that's our guy. That's essentially how we tackle this up. So let's do just one more of these. Oh, what you would get in WebAssign is 5 pictures. One of them would look like ours, and that's the one you would choose. So I'm going to pick one of their questions. Let's see, we can do that guy. Okay. What I'm going to do is similar to question 22. So we have 4x squared, take away 16x plus a 17. And this guy is going to be x squared, take away 4x, add 1. Okay, so we're looking at, in no particular order, Let's get the x-intercept. So I know that the bottom is an x minus 2, x minus 2. Not really sure what the top's going to look like. I wish that was 2 negatives. That's not going to factor, is it? No, it's not going to factor. In fact, if I try to solve 4x squared taking 16x plus 17 equals 0, I know it doesn't factor. If I do x equals negative b plus or minus b squared over 4ac all over 2a, I'm going to find out that that is a negative number inside the square root, so there are no x-intercepts. But let's just prove it. Plus 16 plus or minus 16 squared, take away 4 times 4 times 17 all over 8. On my calculator, I'm about to do 16 squared, then take away 4 times 4 times 17. I get the answer. Oops. 16 squared, take away 4 times 4 times 17. Let's see what that is. That's better. I get the answer, negative 16. And we know that there are no real numbers that you can get out the square root of 16. So that means there are just no x-intercepts. And we would say DNE. Well, maybe I'll get lucky on the y-intercept. What's that? 4 lots of nothing, take away 16 nothings, add 17, nothing squared, take away nothing, add 4. Yep, there is a y-intercept. And it has coordinates 0, 17 quarters. The x-intercept does not exist. Okay, let's do horizontal asymptotes, see if there is one. Well, it behaves as a 4x squared on the top and an x squared on the bottom, which is 4, which means it does have a horizontal asymptote, and its equation is y equals 4. Let's do vertical asymptotes. Well, to get vertical asymptotes, we need to solve what makes that guy 0. In this case, we just get the same answer twice. Doesn't mean there's 2 vertical asymptotes, it just means there's one vertical asymptote at x equals 2. So we have a vertical asymptote at x equals 2. So now we need to figure out what shape it is. So we have test points. And the test points are going to be 1.9, 2.1, and I'm going to evaluate this guy at both those points. So this guy, well, I can't really do that in my head, so I'm going to do it the old-fashioned way. Actually, I am going to do it in the calculator. So although you can't see it, this is what I'm writing down. I'm doing 4 times 1.9 squared. Take away 16 1.9s. Then I'm going to add 17. Now let me just show you me doing that. You might as well see me hit the buttons. Right, so there's that guy. Then divided by, put a bracket in. Then on the bottom, it's going to be x squared, so that's going to be 1.9 squared. Take away 4 times 1.9. Add 4. After all that hard work, I get the answer 104, which means it's positive. Now I want to do the same calculation with 2.1, so I'm going to use the trick second enter. And then I'm just going to go to all the 1.9s and turn them into 2.1s. Okay, where did that come? You hear some barking. It's my dogs telling me that there's a leaf falling in the yard, or someone's just walked by, or they're just talking to other dogs. They're not too bright, but we love them. Well, that's pluses, right? There we go. So I can tell you, if we start putting all of our information onto this diagram, this is what my sketch would look like. Well, there is a vertical asymptote at x equals 2, and it goes that way on both sides. There is a y-intercept here, which I'm going to call 17 quarters. And there is a horizontal asymptote of y equals 4. By the way, 17 quarters is 4 1/4, so y equals 4 is just underneath it. So I try and figure out how to make all of this work. So it looks to me like that should just basically curve like this, and that should curve like that. And that's it. It's basically a big volcano. So I'm now going to go and check that on a calculator rather than a Desmos, because sometimes you don't have access to Desmos. So I'll go y equals, and I have on the top, so I need brackets, 4x squared, take away 16x, add 17. Do a divide, start another bracket, do x squared, take away 4x, add a 4, close the brackets. I'll go to a window. Looks to me that if I do a window from -1 to 4, that would be a pretty decent window. And then I'll just do zoom 0. And it's doing its thing. And of course, the scale is horrible. So I'll go back to my window. And you can see the values are just ridiculous. So I'm going to take this value here and make it -2. And I'm going to take this value here and make it, say, 20, and regraph it, and we might be able to see a little bit better. Okay. Now, I said that there was a horizontal asymptote at y equals 4. Let's check that. There you go. Success. So that is our second. I will do one last one. And the last one I'm going to do is one that has a slant asymptote. And you might say, well, how will I know I have a slant asymptote? When you try and find the horizontal asymptote, instead of getting y equals 2 or 7, you end up getting y equals x squared or 2x or something like that. Whenever you have an x on the top like that. Well, of course, we didn't do one, but suppose you did a horizontal asymptote and it's simplified down to 10 over x squared. That means y equals 0. That just means the x-axis is the horizontal asymptote, and that's fine. So all I need to do now is find a question that I know has a slant on it, so I can do a slant version of this. They're pretty hard to come across because there's only a few that look like it. So here's one. Oops, wrote it down wrong. Try that again. Can you got it back to front a little bit? There we go. So we are going to go through, sketch this guy. And, okay, what am I going to do here? Well, it doesn't really matter what order. Let's do the x-intercept first. Well, you need to solve when it's the top 0, which comes out as that. So it has an x-intercept of 0, 0. To get the y-intercept, I find the value of the function at 0, which is 0 squared, 0 over 4. 0 over negative 4 is 0, which means that the y and x-intercept is the origin. They're both the same. Let's do a vertical asymptote now. Well, for this rational function, the vertical asymptote is going to happen at x equals 4. And that means at x equals 4. So we're going to have that guy, right? And I'll do some test points. So my test points are going to be 3.9 and 4.1. That way I can find out what shape this vertical asymptote is. And at 3.9, the answer is negative, and at 4.1, the answer is positive. So I know that it goes down on this side and it zooms up on that side. It's a one of each. And that is my vertical asymptote. Now I'll try and do the horizontal asymptote just to show you why it's not a horizontal asymptote. Well, the surgery is x squared over x, which is x, which means that it has to be a slant. So I'm now going to do very simple long division. What do you multiply x by to get x squared? You multiply it by x. Then you do the multiplication, which is x squared, take away 4x. You finish with x squared, take away x squared, gone. Nothing, take away a negative, gets me 4x. I guess if I wanted to, it'd be 0x's and 0 here. Right. X goes into 4x. Now you need to multiply it by 4 to get that. I guess you 4x take away 16. You do the multiplication. Then you subtract. That kills that. Nothing take away a negative gets you 16. That is my slant asymptote. It is x add 4. Don't really need to worry about the remainder. Doesn't tell me anything very useful. So we have a vertical asymptote, a slant asymptote, and a few other details. Let's put them all onto one picture. Well, this Okay, so let's put all the information from that graph that we've collected for the graph of this function. So we have a y equals x plus 4. So if I draw the line y equals x plus 4, it looks something like that guy. That's that taken care of. I have a vertical asymptote at x equals 4. You see it? And it had a shape. There is up there, like that. And on this side, it was down here like that. So that's that taken care of. We had an x and y intercept, which is here. And so if I put the information that I've got, those have to join. This has to come, and then it can't really cross this, because if it crosses this and then it has to come here, it's going to have to do the x-intercept. So I'm going to bounce off that and do that. So my best prediction is that this is what the graph of our function x squared over x take away 4 looks like. So what we'll do now is we'll go and have a look at Desmos and see if it agrees with us. Right, let's cross over and try it out. So it's y equals x squared and on the bottom, next minus 4. Right, so what I now need to do is, there we go. Now, I may want to change my scale a little bit, push this up and down a little bit. Let's put in the slant, which was, what was it, x plus 4? Yeah. So y equals x plus 4. Now, you see, it did all the features. There's the x and y intercept at the origin. There's that straight line, the slant. There's the vertical asymptote. I guess I could put its equation in. But if I click on this guy, I can actually make it dotted there, or maybe dashed. There you go. That looks nicer. And if I click on this one, I can make that dashed as well. So, pretty convincing. We have a match, and that means that we have now got a decent sketch of essentially any rational function that contains polynomials on the numerator and denominator. That's bye for now, and we'll take up section 9, subsection 9, applications.